Hey, y'all, I hope you had a wonderful spring break. Today we're going to jump into section 11.1. So we're starting a new topic and it's geometry. Um, and this section is not going to be on the midterm. So 11.1, 11.2, and onward are going to be on the second. So let's talk about a little bit about geometry, kind of an overview. And if you took standard geometry in high school, you'll probably remember some of these things, but it might have been some years ago, depending on when you graduated high school when you took geometry. So we're going to, in this lecture, talk about the basic terms and definitions of geometry, shapes, notations, how to label things, the properties of different things. So points, lines, and planes. A point, as you can see in this picture here, is single, it looks like a dot. Point A, point B is how you label these guys right here. A line, as demonstrated here, a plane, think about it as a tabletop. Um, this is line M. So there's several ways of identifying this line. One is line M. If you notice, it's lowercase and it's italicized. That's one way to label lines. Another one is to label them with the 2 points, two of any points that it passes through. So you can say line AB, or this symbol right here means line, and you can label it from A to B this way, or you can label it from B to A. So either any of those four are correct. This is plane ABC or plane gamma. So those are some ways to identify and name different geometrical terms. A line has no thickness. It extends forever in two directions. We must have 2 points. And this is a theorem in geometry or an axiom. Given 2 points, there's one and only one. That means it's distinct that connects those 2 points. So 2 points define a line. Any 2 points define a line. If P and Q are any 2 points, we can create the number line on the line PQ such that there's a one-to-one correspondence between the points and the line in real numbers. So points, you need two of them to make a line. Now this are some more terms for you. Collinear. Hopefully that term is familiar, but if not, let me explain the co. Co means together, right? If you're going to cooperate, you're going to work together. If you're going to be coordinated, your body works together. So co, teacher, teachers that teach together. Collinear are points that share a line, right? So A, B, and C are collinear. Now D is not. So points ABC are belong in line L, ABC are collinear, A, B, and D are not collinear. Now I could draw a line through any of these points, like AD could be a line, BC could be BD could be a line, and DC could be a line, but I can't make D be on the line with ABC. Point B is between points A and C. Point D is not in between, okay? A line segment is just a segment, a part, a piece of the line. So if you notice, what's the difference between these two? This one has arrows, this one does not, so this is line segment. And you can label it from left to right or right to left. That is how you label a line segment. Notice here that we have open circles and closed circles. So if that happens, subsets of lines are sometimes identified with a half open or half closed segment. So it's just a segment without an endpoint. More notation things, array is kind of looks like half a line. All right, it's like you're starting in the point and you're going forever in one direction. So you need 2 points to define a ray because you need to give it some kind of direction. So one ray here would be the ray AB, or you could look in, let's see. So this guy right here is the ray AB. This, if I wanted to start here, this would be ray CB or CA. So ray is a subset, that means a part of a line, but it contains an endpoint and then all the points that go in one direction. Half line BA denoted by BA, half line BC denoted. So that's just where it has the open circle. A half line is a ray without an endpoint. Now, coplanar, just like that word collinear meant it was on the same line. Coplanar means you have points on the same plane. Now, you need 2 points to define a line. 2 points to define a line. They make a line. And you need 3 points to define a plane. Okay? So D, E, and G are coplanar. D, E, F, and G are not. Let's see, D, E, D, F, and F, E, coplanar. So again, you have these 3 points. Now talking about these 3 points. These would also be on a plane. Imagine if I drew a plane coming up this way, 3-dimensional, sticking through this plane. D, E, and F would be part of that plane. Lines D, E, and E, G are collinear because you can see they're both on that plane. Lines D, E, and E, G are intersecting lines. They intersect at point E. Lines G, F, and D, E are skew lines. They do not intersect. So G, F, and D, E. Those are like this. They're on different planes. So they're never going to intersect. And so we call lines that never intersect skew. That's just the definition. So skew are lines that never intersect. So these lines are 2 completely different planes. So they're never going to intersect. Concurrent lines, lines DE, EG, and EF are concurrent lines. They intersect at point E. 9M is parallel. Okay, so parallel means never cross, like railroad tracks. So parallel, this unit is a lot of memorizing definitions, okay? One way that I help remember parallel is parallel has those 2 L's in it. So remember those 2 L's, they are parallel. The 2 L's are parallel. And this is the notation for parallel. M is parallel to N. It means they have no points in common. They do not cross. There is exactly 1 line that contains any 2 distinct points. I've already talked about that. If 2 points are in a plane, then the line containing the 2 points lies in that plane. If 2 distinct planes intersect, then their intersection is a line. There's exactly 1 plane that contains any 3 distinct non-collinear points. Okay, so again, so it means two of these can make the line, right? But if I have 3 points and they're not all collinear, then that's going to make a plane, okay? So 3 non-collinear points define a line and a point on the line determine a plane. Now, this is just a different way of thinking about what we just said, because again, I said 2 points to find a line, right? So it's still 3 points. It's just now say I decide to say, here's my line right here. So I have a line and then I have another point, right? So a line and a point, not on that line, determine the plane. 2 parallel lines determine a plane. Again, that makes sense because I can have 2 points here and I can actually have 2 points here and I just need 3 to make a plane. 2 parallel lines determine the plane. 2 intersecting lines determine the plane. So if I have intersecting lines, that means by definition, I would have like A, B here maybe, and like B, C here. So do I have 3 points? Yes. All of those situations go back to the fundamental idea that there's 3 distinct points that define a plane. And you can also define them with letters. So this is like plane alpha, plane beta. They're parallel to one another. Whereas these intersect, the intersections of a plane of planes are lines. So if you imagine like I had pieces of paper and I wanted them to intersect, I would need to do that thing. This sorry. So imagine this plane and this plane intersect. Their intersection is a line. Okay, so the intersection of two planes is this right here, which would be a line. So that's this picture AB there. Half plane is what it sounds like. So a half plane is a subset of a plane that consists of all the points on the plane on the same side of a line. So I'm going to switch over to angles. Angles are formed by 2 rays with the same endpoint. Sides of the angle and the vertex. The vertex is like the point. Okay, so this guy is the vertex. We can label this several ways. We can say it's just angle B with just the vertex. We can say angle A, B, C. We can also say C, B, A, and we can also call it angle 1. Adjacent angles, two angles with a common vertex and a common side. So these two angles are adjacent. Adjacent just means side by side. Angle alpha and angle beta are angle QPR and RPS. When you label an angle, the center is always going to need to be that vertex. So angle P, this is the vertex, right? P is the vertex. So QPR is this part. RPS is that part. This is angle measurement. A degree is one of 360 of rotation of a point. A minute is 1/60th of a degree. A second is 1/60th of a minute. And so those are just degrees, minutes, and seconds. Find the measure of angle BXC. So let's see. 47 degrees, 45 minutes. Okay, so if I have 47 degrees, 45 minutes, angle 2 is 29 degrees, 58 minutes. BAC is 1747. Find BAC. Okay. So it told me this big angle here, this whole part here is 47 degrees, 45 minutes. And then it told me this part right here is 29 degrees, 58 minutes. So how would I figure out this missing piece? I would need to subtract, right? I would need to take that 47, 45 minus 29, 58. But what do we do about the minutes? Well, if you remember here, a minute is 1/60th of a degree. So I could say, well, this is like 47 and 45 60ths minus 29 and 58 60ths. Okay, so I subtracted, then I would get 18, but then 45 and 58. If I subtract those two, I get a negative 13 over 60. Okay, so that means this is actually going to be 17 because I'm taking away, right? So it's like I'm taking this 18 and subtracting 13 60th. So I'd be left with 17. And then if you subtracted 60 minus 13, that's where you get your 47. So that's how they got 17 degrees and 47 minutes. Express 47 degrees, 45 minutes, 36. Okay, so again, using this idea. So you got 1 over 30, you got 1 over 60 and 1 over 60 again. So this is 47 degrees plus 45 out of 60 degrees plus 36 out of 60 times 60 degrees. Okay, so if you do that, 60 times 60, that's 360, right? 36 divided by 60 divided by 60 is 0.01. So the reason why there's two 60s here is because this one is out of 60. And then this one is out of these out of 60. Okay, so you're going to have the 260, which will both be in the denominator. So it'd be 36 over 3600, which is the same as 1 over 100, which is that 0.01. So that's how we got this 47.76 degrees. Types of angles, acute, right, and obtuse. So acute, I just always remember, oh, isn't it so cute? Because little things are cute. So those are the ones that are smaller than 90. Such a cute little angle. Right angle, a straight up and down, like the sides of a paper, the sides of a square. Obtuse is bigger than 90, and then a straight angle is like this, where it's 180 degrees. So a line. A circle is the set of all points in a plane that are the same distance from any given point. An arc is any part of the circle. So circle center O here, the way you would draw a circle is you measure a distance and then you keep that same distance all the way around. So a circle is the set of all points that are the same distance from any given point. A chord is a segment that goes across the circle that's not the diameter. The diameter is what cuts the circle in half, and then the radius is half of the diameter. Any segment within points we just talked about that. Minor arc is one determined by a central angle whose measure is less than 180. A major arc is greater than 180. An arc determined by the diameter is a semicircle. Okay, so let's just talk about those terms for a minute. So this is a minor arc because it's less than 180. 180 would be halfway across. Okay, this is also a minor arc, and this is also a minor arc. Those are all minor arcs. AD is the semicircle because it's literally half of the circle. So semicircle means it's exactly half of the circle. But if I make a bigger arc, so let me change my color. If I go ACB, so let's see. A C B. So I had to go this way to get to the C first. That's a whole bunch of the circle, right? That's past 180 degrees. So that's called a major arc. As you've gone past 180, bigger than a semicircle, essentially. Find measuring mark measure arc and B. Okay, so AOB. There's AOB. So if this is 60 degrees, this line, these two angles make up 180 degrees because there's 180 degrees on any line. So that means whatever this is needs to add with 60 to be 180. So what would that be? Well, that would be 120. And whatever the measure of this central angle is right here, that's the measure of the angle of the arc. So the arc would also be 120. Okay, so that's easier because it's already labeled 60. And so this is the arc associated with this angle. And so it is also considered 60 degrees. Oh, see. Okay, this one has a little bit more. Let's see. So again, this was 120, if you remember, because these two need to add to be 80. Now these two need to add to be 180, which means this one's 60. Or there's a principle that say opposite angles are congruent to one another. So since this is 60, I need that 60. So BOC, that angle is 60, which means its arc right here is also considered 60 degrees. F, F, D, C. Okay, so we need a bigger O. So FDC is this arc right here. And the angle that's associated with that is this one right here. So that means this guy right here and 60 need to add up to be 180 because they are on a line. And the line is 180 degrees. So that means that the X, that missing piece, will be 120. And if this is 120, that means that its arc is also considered to be 120 degrees. Perpendicular lines. This is the symbol for perpendicular. It looks like an upside down T. And that means they intersect with a degree of 90 degrees. Perpendicular, 90 degrees. So AB is perpendicular to BC. BA is perpendicular to BC. These are all the different ways we could say this. AB is perpendicular to, that's the same as that, repeated, but our line M is perpendicular to line N. A line perpendicular to the plane is a line that is perpendicular to every plane and every line in that plane. So, so like this line right here, AB is perpendicular to every single line in that plane alpha. which I think makes sense if you have like a 3D shape like this. So if I was to stand up another piece of paper here, any line that I would draw on this piece of paper here is going to be perpendicular to the plane below, no matter where it is. Any line on this piece of paper is going to be perpendicular to this one, if these two planes are perpendicular. If P is any point on A, D, Q in plane alpha and S is in plane beta, so that Q is perpendicular to AD, then QPS is also a right angle. Since QPS measures 90 degrees, the planes are perpendicular. So it says PQ is perpendicular to AD. And then it said PS was perpendicular to AD. Okay, so basically there's two lines that are perpendicular to this one other line. And if that's the case, then that means that these planes are also perpendicular. Dihedral angle is formed by the union of two half planes in the common line defining the half planes. A dihedral angle is measured by any of the associated planar angles. So this is LBD, it's LBD. Where PO is perpendicular to AC, and then BD is perpendicular to AC. So di means two, so it's a union of two half planes. Okay, I know that was a lot. It was a lot of definitions. Hopefully this side note will help make things more clear. But please, as always, reach out with any questions. Big concepts are how to label things. And then also that there's 2 points in a line. Ray is in one direction. Segment is just the endpoints. Planes need 3 points. And then the idea of parallel, never intersect, perpendicular 90 degrees. Angles that add up to 180 is a straight angle. Obtuse is greater than 90. Acute is less than 90. Right angle is equal to 90. Measure of an arc is equal to that measure of the central angle. And so yeah, those are some key ideas. Hopefully that helps. Please reach out with any questions.